So I will be discussing the three ways to solve enthalpy problems. So the first way is Hess's law, the second way is bond enthalpies, and the third way is standard enthalpies of formation. So for the first one, Hess's law, in this example, we have nitrogen dioxide, which is formed in two steps. So when adding these two equations together, the 2NO right here and the 2NO right here, those cancel out, and the net reaction is N2 plus 2O2 forms 2NO2, and all this is in gases. So as you can see, these just cancel out and bring whatever is left down. And so since we added these, we have to add the delta H's. So the delta H of reaction 1 is 180 kilojoules, and the delta H of reaction 2 is negative 118 kilojoules. So we do delta H of reaction 1, reaction 2, plus delta H of 2. You get 68 kilojoules, and since that is positive, it's an endothermic reaction. So that's using Hess's law. Now we can use bond enthalpies, and for bond enthalpies, it's going to be the bonds broken minus the bonds formed. So the first thing we want to do with this equation is balance it. So right here we're going to need to put a 2 for the O2 and a 2 next to the H2O. So right here we have 4 O's, 4 O's, 4 H's, 4 H's, 1 carbon, 1 carbon. So now that we have balanced it, we need to calculate the bonds broken minus the bonds formed. So what is given to us in this problem is that a CH bond is 412 kilojoules per mole, and O2 bond is 496 kilojoules per mole, and a C double O bond equals 743 kilojoules per mole, and also an OH bond equals 463 kilojoules per mole. So for CH4, it's gonna be CH, CH, CH. You're gonna have 4 of those CH bonds. For 2O2, it's just gonna be O with 1 double bond. However, you have 2 of them, so you're gonna have to write another one down there. And then for CO2, it's going to be C double bond O double bond O, and you only have 1 of those. And for 2H2O, it's going to be, that's water, but you have 2 of those. And so you're going to want to do the bonds broken minus the bonds formed. So right here for CH, you have 4 bonds. So that's going to be 4 times 412, since 1 CH1 is 412. So it's going to be 4 times 412 kilojoules per mole, plus, and then here you have 2 O2 bonds, and O2 bond is 496 kilojoules per mole, so it's going to be plus 2 times 496 kilojoules per mole. And those are the bonds broken. And now you're going to want to subtract the bonds formed. And so right here you have CO2, which is going to be 2 C double O bonds, so 2 times 743 kilojoules per mole. So 2 times 743 kilojoules per mole, plus here you have one OH bond is 463 kilojoules per mole, but right here we have 2 OH bonds on this and 2 OH bonds on this. So 2 plus 2 equals 4 times 463 kilojoules per mole. If you add these up and add these up and subtract this from this, the answer is going to come out to be negative 698 kilojoules per mole. And so that's bond enthalpies, which is just bonds broken minus bonds formed. And the last one is standard enthalpies formation. And for this, what you're going to want to do is the sum of the products, the delta H of the products, minus the sum of the delta H of the reactants, delta H of formation. And so in this problem, we have CH4 plus 2O2 to form CO2 plus 2H2O. And so we're just going to want to add the products and the reactants. And what was given to us, as well as the last problem, we got numbers given to us, are these three right here. So right here we have a number for CH4, delta H of formation for CH4. We have a delta H of formation from CO2, delta H of formation of H2O. However, we do not have one for O2, but since O2 is just an element in its standard state, that is going to be 0. So if we're going to want to do the delta H of formation, it's going to be products minus reactants. So CO2 plus 2H2O, you have to count the coefficients. And that's a reminder, just always remember to balance your equations. Plus 2OH2O minus the reactants, which is going to be CH4 plus 2O2. And so CO2 is negative 394 kilojoules per mole. 4 kilojoules per mole. H2O is negative 286. However, that's going to be multiplied times 286 kilojoules per mole. And those are your products minus your reactants. CH4 is negative 75 kilojoules per mole. Negative 75 kilojoules per mole. And O2, again, since is in the standard state, it's 0, so plus 2 for the coefficient times 0. And then once you solve all this, the answer is going to be negative 891 kilojoules per mole. So that's the 3 ways to solve enthalpy problems. The major thing to remember about all these is for Hess's law, you just have to cancel them out and add them if you are adding them. Also for Hess's law, if you ever need to switch an equation backwards around or anything, you just have to change the sign on the delta H. So if we switch this one to here, the delta H will be negative 180 kilojoules per mole. And for bond enthalpies, it's always going to be bonds broken minus the bonds formed. And for standard enthalpies of formation, it's always going to be the delta H of formation of the products minus the delta H formation of the reactants and the sum of each. Thank you.